Hi, this is Shane with Ozone Water Systems. Today we're going to go over our larger series Destructs. This model is a 100 CFM, but what we're going to talk about today mostly applies to all the larger ones from the 100 CFM, 200 CFM, and also the 400 CFM model. All the components are basically the same, just a slightly different layout and obviously different size blower, different size media tank for each of these models. Starting at the inlet side, we have a water trap for capturing any liquid water that may come off from the process tank where we're pulling the off gas from. They will vary by shape and size, but they have the same job. The inlet tube here has got the suction from the blower. That goes to the top of your contact tank. Any off gas will be drawn in from here. The top of that contact tank will have a inlet, or generally have an inlet or a filter system to allow ambient air to sweep across the top of the tank, and also so we don't put a vacuum on the tank and potentially cause damage to the tank if it's a low pressure or atmospheric tank. This air will be coming from the top of the tank. It may or may not have any moisture in it, but if there is moisture in it or liquid, that liquid will come in here and get trapped in the bottom of this water trap. You want to keep water in the P-trap at all times. That prevents off-gassing from potentially leaking out of the drain, because we have that water barrier in there. Just as an example, we would normally have a little more water in this, but right now we have water up to this point. There is a little sight window in this tube that goes from the bottom of the water trap up to the top to indicate how much water's in it. Right now we have it up to here, and there is a proximity sensor that reads the water level. If the water gets emptied out of the water trap, it will trigger an alarm, which we'll talk about in the control panel, and give you notification that there is no water, so you need to refill it. Normally you'll have it up 12 inches or so off the bottom of the tank. It does just need to be below the drain generally, but if you are filling it up through the fill port here on the back side, you can just fill it up until it comes out of the drain, and then you can stop. It doesn't have to be that full, but that's just an easy way to just fill it up. There's a light on the proximity sensor. That light will extinguish if there's no water being detected. And you'll also get an indication on the control panel. The fault lamp will turn on, and the panel lights in the panel will turn red. It does not stop the blower from operating, but it will give you an indication that there's a fault, that you need to put more water in this. Off gas comes in here and it goes into a chamber, and that chamber flows up through around the outer side of that center tube, and those demisting media balls will collect any liquid or humidity that is coming off the off-gas tank, and those will then drip down into the bottom of the water trap. Once the off-gas comes up through the media balls, then down through the center pipe, that goes down all the way to the bottom and comes out down here. And that goes into the bottom of this media tank. This has got the Destruct media housed inside of it. That off-gas or ozone-laden gas will then flow up through the Destruct media. Once the ozone comes up through, here's the media. This is the Kerolite media that destroys the ozone, turns it back into air, or just oxygen. It has a consistency of like kitty litter. Kind of looks like carbon. That will destroy the ozone coming up through it, and then it will pass through this screen that prevents the media from being drawn into the blower. That goes into the blower, and then out of the blower, this will then be vented out outside of your building generally. It is just safe, normal air coming out of this, so it can be discharged safely into the room. Often it's vented out the ceiling or out of the wall. Bottom of the sight tube comes out of the bottom of the water trap with a T, and then it goes around here. The side of the T has a plug, and if you ever need to drain the water out of the P-trap, you can just pull that plug out and drain all the water out of it. If water ever gets into the bottom of the media tank and that float switch is triggered, there is a drain plug in the bottom of the media tank. Get a look at that over there on the side. So if there gets water, if you need to drain it, pull that plug out and you can get the water out of the tank. On the side of the Destruct media tank, through this elbow, there is a vacuum relief valve. And the purpose of this valve is to allow air to pass into the media tank should the incoming pipe plumbing be plugged up. If this pipe becomes plugged, somebody leaves the valve shut, or there's a problem with the tank, we don't want to put too much vacuum on the tank. This vacuum brake will allow air to enter the tank to prevent excessive vacuum on the system. The larger Destructs have 2 MagnaHelix gauges for system monitoring that will tell you the status of your system. One for the Destruct media and then one for the blower section. We're going to, different video, I'll go over what these indicators mean. If you see a certain value that differs from the initial parameters established when you first install your system, then you'll know what to look for on that. We'll talk about that in another troubleshooting video. These MagnaHelix detect the pressures on the incoming side of the media tank and the outgoing side of the media tank, and also to just atmosphere. Alternately, that fitting can be tied into the discharge plumbing downstream off of the outlet, more accurately represent the differential across the blower, and that'll tell you if there's a problem with the blower. Bottom of the media tank also has a float switch to determine if any water enters the media tank. If for some reason water makes its way past the water trap into the bottom of the media tank, we need to know that, because water will destroy the media in the Destruct. So if water enters the bottom, lifts the float, it'll open that contact, and that will trigger the blower to stop and also indicate a fault light on the panel and turn the panel red. Because if if there's water, liquid water in the bottom of this tank, we've got to stop the blower, because we will ruin the media as well as potentially the blower if we allow water to get drawn up through the media. In the control panel here, so we've got a fault light and a blower on light and a blower on off switch. These systems generally run 24 hours a day. Anytime there may be any ozone in a contact tank, the Destruct needs to be operational, because if it's not, that potentially there could be ozone off-gassing of unsafe levels entering the room, potentially where operators are working. The blower has an overload that will also trip the fault light and shut off the blower. Like I said earlier, if the water in the P-trap gets empty, it will trip the red light in the system, but it will not shut off the blower. Blower will only turn off if the float switch is triggered or the overload is tripped. When you first install the system, we run them and fully test them here at the shop, but without all your plumbing installed, we cannot document or know what your default normal operational MagnaHelix readings will be. Those will be determined at startup when all the plumbing is installed and we know what the back pressure is on your system and what your nominal numbers are. And then from those numbers, we generally suggest making a mark, what normal is, go up or down from that point. After it's been operating for some time, then you know if there's a discrepancy in the system. Bottom of the tank does also have a heater element that warms the air as it comes in, and that's to dry out any condensation that will be in that off-gas stream, because it's generally humid air coming in. And we want to try to dry that out or evaporate it before it gets into the Destruct Keras media. The media does last for some time as long as it's kept dry. If it does get moisture into it, it can clump together and cause problems with the water, the airflow through it. It can do what's called channeling if it gets plugged up, where you'll have particular routes where the air will come through it if it gets clumped together. And then it won't work efficiently because it can't contact all the media. So it's important that the media be kept dry and inspected periodically to make sure. Now you'll know if there's an issue with the media generally if you look at the MagnaHelix gauges that we'll talk about in the diagnostic video to tell you if there's a problem with the media, if it needs to be looked at. But probably once a year, regardless, it would be good to pull the lid off and inspect the media and make sure that it looks good and that it's not clumped together, that it's still loose and in individual pieces, because as it gets clumped together, you lose the surface area and it can't do its job. Now let's start it up and I'll show you the normal values you'll see. We'll try to simulate a few faults so you can see what the lamps do in the control panel. All right, the noise will get pretty loud in here when we turn this on. Hopefully you can still hear me. We're going to switch the blower on and we'll watch the MagnaHelix gauges rise. So in this configuration, without any plumbing on the inlet or the outlet, here's the numbers that we see for the Destruct. That's the media bed. And then the blower in and out shows us that. So if that was our numbers from when we were starting it up, we would make a mark at those values so that we can tell if there's if it ever changes from that. Let me simulate an overload trip. So that simulated an overload condition of the blower, and as you can see, our red LEDs in the panel light up to show you from across the room. You can tell there's an issue, and we have a fault lamp illuminated, as well as, of course, the blower is shut off. If the float switch in the bottom of the media tank is tripped, you'll see the same condition. The fault light will turn on and the panel lamps will turn red. If it is the proximity switch in the water trap trips, the blower will stay on, but you'll see the same condition on the panel. You'll get a red lamp and a red LEDs in the panel will trip. But the blower light will stay illuminated green if it's just low water in the P-trap. That's not a situation where we need to or want to stop the blower. We just need the operator to be aware that that needs attention. If you do need to reset the overload, the blue button here on the overload will reset an overload condition. We currently have it set for a manual reset, so you'd have to come in here and reset it yourself. You can set it to auto, but we generally don't have it do that because if it tripped, we would like to give it some attention and find out why it tripped. The overload setting will obviously depend on the size of Destruct we're working on. This particular one is set for 3 amps. That can be adjusted here. The overload used in the different models may not be this exact same ABB model, but it'll have the same basic features. So we can reset that with the manual reset button on the blue button here. And your blue lights will turn back on. It'll clear your fault lamp. One note on startup, when you're first commissioning the unit, you do want to, this is a 3-phase blower, so you do need to make sure that the rotation is correct. Clockwise is what it's supposed to be, and we can see here right now this is rotating clockwise. You can just bump it over. You don't want to run it for too long in the wrong rotation, because as we can see it is rotating clockwise. So you'll want to double check the rotation on commissioning and startup, or if there's ever any wiring changes to the system, make sure that the rotation is correct. Most of our Ozone systems have an input for Destruct status, so that we don't make Ozone unless we know the Destruct is running. In this system, terminals 63 and 64 right here close whenever the Destruct is operational. So you would connect in at the bottom of those terminals right there. The DC power supply here, 24 volt DC power supply, and these blue circuit breakers here are DC circuit breakers. So anything DC powered, these are the circuit breakers for that. And these, of course, are your AC circuit breakers. There's one 3-pole breaker and 2 2-pole breakers in this particular unit. Those are going to vary slightly between unit to unit. So review your electrical diagram for your particular unit if you're working on the electrical for your particular Destruct. Thank you for watching this demonstration of our larger size Ozone Destructs. If you have any questions, as usual, feel free to call our offices at 480-421-2400. Ask for tech support, or you can email us at info@ozonewatersystems.com. Thank you for watching.